Hello kids, again I'm back with Standard 8 Mathematics. Chapter is Square and Square Roots Part 2. Here we will understand a unique pattern of finding the squares of a number, or to find the sum of n numbers as 1 square is 1, 2 square 4, that can be written as 1 plus 3, 3 square that is 9, that can be written as 1 plus 3 plus 5, 4 square 16 can be written as 1 plus 3 plus 5 plus 7, 5 square 25, that can be written as 1 plus 3 plus 5 plus 7 plus 9. What do you observe from the following pattern? That the number of terms will give the square of the number, and sum of these numbers will also give the square of the number. And if you'll follow that these numbers are odd numbers, means to get the n number of odd numbers, sum of that can easily be found out by number of terms. Square of that will get the sum of the n number of odd numbers in a series. So every perfect square can be expressed as the sum of odd numbers. Let us take another example. 1 plus 3 plus 7, all the odd numbers up till 49. So from 1 to 50 there are 25 odd numbers and 25 even numbers. So 1 to 49, 25 is the number of odd numbers. So to get the sum of this series, we will find out the square of the number of terms or number of odd numbers, that is 25 square. So sum of this series is equals to 625. Now let us move to another property of squares, that is Pythagorean triplet. Here we have taken a right angle triangle where the hypotenuse is square, that is the side opposite to the right angle, is equals to sum of the square of the other two sides. If one of the side is 2m, other two sides will be m square plus 1, m square minus 1, where m square plus 1 is the longest side. So 2m square, from there we can find out, yes, both the square of m square plus 1 is equals to 2m square plus m square minus 1. So let us understand this with an example. If one of the side is given as 6, then to get the value of m first, to get m square plus 1 and minus 1, other two sides, what we will do, 2m, that is the one of the side, that is equals to 6. So m is equals to 3. So other side, m square minus 1, putting the value of m, 3 square minus 1, that is 9 minus 1 is 8, m square plus 1, 9 plus 1, that is 10. So the three sides will be 6, 8, 10. You can check that 10 square, that is the hypotenuse square, that is the longest side square, is 100, 6 square is 36, and 8 square is 64. 64 plus 36 is equals to 100. Now let us move with some identities of squares, like a plus b whole square is a square plus b square plus 2ab. So how we can use that identity to get the square of big numbers, like if the number is 102 or 103 or 205, how we can get? We will write it in terms of a plus b, that is 100 plus 2 whole square, that is 100 square plus 2 square plus 2 into a into b. We can easily find out. Otherwise we have to find out 102 into 102. This we can do orally. 100 square is 10,000, 2 square 4, 2 into 2 400, and we can add easily. Similarly, another identity is a minus b whole square. If 98 square you have to find, either you can do 98 into 98, or using identity 100 minus 2 is 98. So 100 square 2 square minus 2ab. A square plus b square minus 2ab. From there, orally we can find out. A square minus b square is a plus b, a minus b. So if an example is there, 59 into 61. So 59 can also be written as 60 minus 1, a minus b, a plus b, 60 square minus 1 square. 3600 minus 1, that orally we can find out by using identities. Means by using the identities of squares, we can orally multiply big numbers. Now we will find out gain square root of a given number by using division method. First we had done by prime factorization, now by division method. Here I have taken a number 1444. The first thing we will do, that will make pairs. As we are doing for square root, so we will make pairs from ones plus. Ones and tens makes one pair, and these two numbers will make one pair. If only suppose 444 will be the number, then last two numbers make one pair and one alone, so that will make alone a number. What we have to do? The first thing that we have to do, we have to multiply with the same number, because to get the square root, that itself means like 2 square, as I said, is equals to 4, means the square root of 4 is 2. We used to form the pairs of multiplication of two numbers. So 3 into 3 is 9. If we will do 4 into 4, that will be 16. So more than 14. So we cannot go for that. We will do 3 into 3, that is 9. We will add here with the same number, so 6. Then we will plus here the number which we will multiply same number here, 68 into 8 here also. So 68 into 8 here also 8 to get 544. Now using this method, how to check that given number is a perfect square? If not, then if have to subtract the least number to make it a perfect square. Same long division method we will do. 3 into 3, 9. We'll add 6. Then 3 into 3 again. We'll get 199. If we'll do 4, we'll get more than 204. So we cannot go for that. The least number, that if we'll subtract 15 from the given number, we'll get 0 in the remainder. So it will make it a perfect square. So we will subtract 15 from the given number to make it a perfect square. That is 1104 minus 15 is 1089, and the square root of that will be 33, because now 15 is being subtracted from 1104. So remainder will be 0. Now we'll go for what is the least number to be added to make the given number a perfect square. Here I have taken example 6203. First we will do make pairs, then we will read out the table. 5 5 is 25, 6 6 is 36, 7 7 is 49, 8 8 is 64. So that is greater than 62. So we will go for 7 7 is 49. 7 plus 7, 14. Then we will carry down the next two digit together always, as we made pair of numbers. In division, we used to carry down one number, single digit. Here we'll carry down pair of numbers. Now we have to multiply 8 into, with any number you have to try out the different numbers you will put here, and like 5 and 5, 8 and 8. So we'll put 8 into 8, we'll get 1184. If we'll put 9 over here, we'll get a greater number than 1303. So we'll go for 8. We'll get 119. But here we cannot add 119 with the given number, because 6203 is a number which lies between 78 square, that is greater than 78 square, and the next perfect square will be 79. Between 78 and 79, no other number can be possible. So 78 square and 6203 lies in between 78 and 79 square. So what we have to add? It is 119 greater than 78 square. We have to find out the square of 79. and subtract the given number. So that much we need to get the perfect square, that is square of 79. So to get a perfect square of 79, that is the next perfect square, because as I told, there is no perfect square between 78 and 79. The next number is 79. So 79 square is 6241. So how much we have to add to 6203? That is the given number that we will subtract from 79 square. So 38 will be added to the given number to get the perfect square, that is the square of 79.